Good morning, everyone. Welcome to today's live session on model deployment. What we are going to do in this particular session is we are going to take a model, we are going to deploy it as a Flask application, and finally, we are going to scale it on multiple deployment environment. We are going to create a container of it. We are going to put it on serverless environment, and we are going to also put it on App Engine. Now, there are multiple other ways of deploying on either on-premise or cloud platform. We are going to see a quick overview of it. So let's get started. Now, what the model that we are going to take is this is how it looks like. I'm not going to deep dive into the training pipeline, but what I have, if you go to this particular webinar description, you can see a link to the video that has details on it, as well as the code where you can go and run it yourself. You can just open in Colab and run it yourself. But I'm going to give an overview, which is more than sufficient for this particular webinar. And second thing is, this can be any pipeline, right? Like you can bring your own pipeline, deep learning or machine learning pipeline. So it can be anything. The process is similar, but let me quickly go through how does the model look like that we are going to deploy. So what we did in this particular video is we took CFPB data. CFPB is nothing but Consumer Financial Protection Bureau. So typically when you complain to a banking system and they don't reply back, what you can do is you can file a complaint against CFPB, and the bank has to respond to them within a particular SLA. So we took data from CFPB. Now, CFPB basically has multiple categories. The complaint can be on a credit card product or a student loan product, or it can be on any product that they have. Just a minute. Yeah. It can be on any product that they service. So what we took is we took a CFPB data. This is a NLP pipeline. We did a TF-IDF vectorizer. Now, what this TF-IDF vectorizer does, it converts a collection of raw document into a matrix of TF-IDF features. So basically, we have a data over here that is completely text. It is just raw complaints data. We are converting that into a numerical format. That's what we are doing over here. And once we are converting into a numerical format, basically we are running it against multiple models. Now, before converting into a numerical format, TF-IDF of scikit-learn by default comes with a tokenizer. But what we have done in this particular model is we have built our custom tokenizer. So the reason is the data has some kind of text that we don't want. We want to kind of take it, we want to remove stop words and everything. So what we have done is we have overridden with our own custom tokenizer. I'm going to show that function when we get into the code. And then basically we are running against multiple models. In this case, I have used XGBoost, H2O AutoML. I am running against multiple models. I'm picking the leaderboard, which was a XGBoost model. And I am running the final XGBoost model, fine-tuning it. It's a multi-class classification problem, and it's a imbalanced data. So I am handling the imbalanced data. And finally, I have a model that I'm going to deploy. So the output of this is I have two parts. One is the vectorizer that I have created. I have saved it as an file, a pickle file, and I have an XGBoost model in this case, which I have saved it as an basically booster file. So this is how my pipeline looks like, right? So what I'm going to do is basically from here on, this is what we are going to cover. The first step I'm going to do is I'm build a Flask application, and we will also see the best practice of building a Flask application. The next part I am going to do is I'm going to cover challenges with Flask and scaling Flask. Flask is good, but it has some challenges. And then we are going to talk about how we can overcome the challenges and understand the Flask deployment patterns. I am finally going to create a Docker container. I'm going to explain in detail how you can create a Docker container and best practices of Docker container. And we are going to deploy it across on-premise and cloud environment. I am also going to show a demo on Google Serverless Engine, that is Cloud Run. And if you have been not following Serverless Engine, there's a good way to learn Serverless Engine, because the future of Kubernetes or containers is going to be serverless. You can also run it on Kubernetes platform, which I will also be talking in my future live session. But here I'm going to focus on Google Serverless Engine and Google App Engine. Now, if you want to equate it to AWS, I'm going to also show like what you can do in AWS. Now, this is what we are going to build. we have an incoming user request or any request coming in, we have a REST API enabled via Flask application. I'm going to collect the data. In this case, it's just going to be a JSON input. I'm going to tokenize and clean run the tokenize and cleaning function, which I have created over here. You can see on the top, which I have created over here. I'm going to run it. I'm going to load the vectorizer that we saved in the training pipeline. I'm going to call the transform of vectorizer and the predict function, and then predict it with the XGBoost model. And then I'm going to run it. First, I'm going to run it in a standalone Flask application. So let me get started with that part. So this is how the code looks like. Let me get back to here. Now, the first thing is I have created a file called complaintsflask.py. And this is how the file looks like. I also have multiple folders. Now, one is, since I am using Python NLTK, I need to download the corpus file. So typically you do a nltk.download in your pipeline. Because I'm going to have a self-sufficient container created, I have downloaded the stopword corpa and the tokenizer corpa file and kept it in my local. So that is one part. I have the model file from it. So I have the TF-IDF vectorizer pickle file, and I also have the complaints booster file, which is nothing but the XGBoost booster file. That's the second part I have. And I have my pre-processing function. So let me open this function first. So here, if you see, this is how my function looks like. What I am doing is I am importing a kind of a regex package and the NLTK package. And when a data comes in, what I am doing is I am just calling my stemmer and stopwords, and this is the tokenize function. Now, what happens when you pickle the TF-IDF tokenizer? Now, if you are using a custom function, the custom function does not get pickled along with the tokenizer. So you need to re-import the custom function. So that's why it's better to create as a separate package so that you can use it for both training pipeline as well as deployment pipeline. And you may have 100 of function when you are dealing with your typical data or cleaning a text. So it's better to have a separate file that you can call within your Flask application. So that's what I have done over here. And in this, I am basically reading all my input text, and I am just filtering all the words that are greater than three over here, and I am tokenizing it. Then I'm converting all my words to lowercase and finally stemming it. And this is how my training pipeline was also there. And as I said, like, you can go and check the code. The code is here. Like, if you go to my GitHub repo, this is the code for it. It's in my GitHub repo. You can go to Srivatsan88 natural language processing, and you can go by this file name. You can find the entire code. If you see, like, basically this is how my complaints data looks like. These were the 6 classes, and this is the distribution of classes. It's an imbalanced data set. And basically this is how my bank level data looks like. If you come down, this is what my data is. Here the user has filed a complaint. You can see the complaint, and this is the text we are cleaning over here in my cleaning function. And finally, it's predicting whether that particular complaint was related to a vehicle loan, or whether it's a debt collection, or whether it's any other category. That's what we are trying to predict over here. And in this process, you can basically see, like, we are using a TF-IDF vectorizer over here, and I am calling this function in the training pipeline. So rather than having the default tokenizer, I'm calling this tokenize function. So that's what basically you are seeing over here. This is the tokenize function that I have copied over here. Now I have this function. What I'm doing is, first I have to import all the regular packages, right? I have my Flask package where I'm calling Flask JSONify and request to receive the request over here. I have my pre-processing package, which has the tokenize function, which you saw over here, the functions.py. I'm just importing the pre-processing.functions, and I'm importing the tokenize function that I have created. Okay, and then I have the joblib package to load my pickle file. I have two basically models. One is the TF-IDF pickle file. So I'm using the joblib to basically load the model, pickled model. And then I have a health check package. And I will explain why I need this health check package as we go into the detail of it. I am also loading like OS and logging. Logging is always a best practice when you're deploying your model in production, you have proper logging in place to know like whether the model is performing as expected. Because sometimes you may see the model is running completely fine, but it has hanged, and you will not realize at all the model has really hanged. So it's always good to have logging so that you can completely monitor your logs and then see whether the model is running as expected. Now, from the logging, I am calling the basic config function over here, and then I'm telling my format of the incoming messages, and then the log level as info. That's what I'm telling. Now, one thing over here is you can also give a file name, and you can tell, if you see over here the basic config, you can also give a file name and you can log it local. Since I'm going to use some of the deployment pattern like serverless, I want to kind of log it on the serverless framework. That's why I'm not given a file name, right? And then I am just calling the app. I'm just instantiating the Flask app over here. Now hyphen name is nothing but the main function calling the Flask app, and I will get the app object. And this app is what I'm going to run and deploy it when I'm running a Flask application, right? This is the application object of it. Now, that's the initial part of it. Now, my target is going to be a numerical value. Because finally what I've done is I've converted my target that you are seeing in the training pipeline into numerical value. My model will give me any of these 1 classes from 0 to 5. There are 6 classes, right? Now I need, when I'm replying back in a Flask application, I want to convert it from numerical back to the actual labels. So that's what I'm doing over here. I'm creating a dictionary object. I'm just telling when it's a 0, it's a debt collection. When it's a 1, it's a credit card or prepaid. When it's 2, mortgage, and so on, right? And then I am loading my models over here. So first I'm loading my TF vectorizer model. I'm calling the joblib.load method, and within the models I have this pickle file, and I am kind of calling that. And next I am basically calling the booster method for XGBoost. So I'm telling like I'm just instantiating the booster object. Now you can give it empty. I'm just telling run it in 3 threads. So it will use all your CPU. It will use your 3 cores of the CPU to run it if you have sufficient CPU. Otherwise, it's just going to run it in a single core, right? So if you have a lot of trees in the booster model, so you can parallelize it as well, and it's an easy method to parallelize it. If you have GPUs, you can also run it on GPUs, right? Now, next what I am doing is I'm calling the load model method over here, and I am loading the booster file. So in this case, what I'm doing is I'm just loading my pickle file and booster file. Now, one thing you remember when you are creating this loading method, don't load within your predict function, which you're calling. You want to load it when the Flask application starts. And this is a good place to load it when the Flask application starts. What will happen when the application starts to load the model and keep it in memory for you? If you're doing it in the predict function, every request that comes in, it will get loaded during the predict function, and it's going to cause latency issue. So always try to load it before and keep it ready. In the predict function, use it only for scoring the model, not for other purpose. Most of the people know about it, but it's sometimes a rookie mistake that whenever people starting with Flask, they don't realize it, right? The next thing is I'm just printing some info statement, in this case telling all models loaded successfully. And in this case, what basically I am going to do is in the log, you can see like all models are loaded when you go and check the log, right? And finally, if you, and now I'm going to talk about the health check. Now, when you call your model, how do you know your model is up? So you want some live probe on your model telling, okay, my model is up. As I said, your model, Flask model may be running. It will be showing like the running status, but due to some other issues with memory or some other, it can hang indefinitely and you will not realize at all, right? So now what I am doing over here is I'm calling this health check package, which is a very nice package to monitor your application. It can be any application, right? So what I'm doing, I'm passing my Flask app object, which I created on the top, and then I am calling an URL. This URL is how you can call from outside. Your deployed URL /health check, when you call, this will get activated, right? And then what I'm doing is I'm creating a function. So whenever this /health check is called a URL, what I'm doing is I'm going to return that I am alive. Thanks for checking. In case if it is not returning anything, that means your Flask app is down. So it is just an way of checking your Flask is like up and live, right? And then what I'm doing, the health object that I created, I'm just doing that hat check. How am I is the function over here. That's what I'm doing. It's very simple, 2 lines of code. It's always a best practice to have it, right? Now that is done. Now what I'm going to do is I'm going to talk about my predict function. Now the predict function in this case is invoked when I call the slash score in my URL. Say if my Flask is deployed in localhost, I will call localhost slash score. That's what it is like. So whenever the slash score URL is called, then my predict function is invoked over here. Now in the predict function, what I am doing is I am basically getting my incoming request that I am getting from the external world. So in this case, I am telling my request.getJSON of text object. So I am passing a JSON object where I am like telling like text colon some text. Right now, I will basically, this is what the text is. If you see, this is the text I'm going to pass. As a JSON object, I'm going to say text colon receive letter or something like that, right? That's what I am getting from here. I'm just logging info of the incoming message. And when you go to production, make sure your infos are very less, only required. In this case, I am just logging all the info. But when you're going to production, maybe you want to change the info level to warning or error only, or have basic info only, right? So that you need to make sure when you are going into production, because you don't want too much of logging as well, right? So then what I'm doing is I am calling the score function. The score function is nothing but I am calling my tf5 vectorizer.transform method, and I'm passing the text object over here. And then I am calling my XGBoost predict on this transformed text, and then I'm getting a score. So this score will call the score function and then give me prediction. And finally, what I'm doing, my prediction is a multi-class classifier. So in this case, basically what my prediction will do over here is it will return 0 to 5 classes. I said like I have, if you see on the top, I have 0 to 5 classes. Now I'm getting the argmax, that is the maximum prediction that I got for that particular class. And that will give me what was the predicted class. So it will give me a number between 0 to 5. And then from that, what I'm doing is, if you see over here, I'm getting target.get. So target is my dictionary object over here. If you come here, target is my dictionary object. I am passing the index that I am getting, and I am getting the text value of it. So this is what I am doing in my Flask application. Okay. And now here, one more function I have created. Now Flask is also a good way of hosting your static HTML file. So if you have some static HTML file, you can host it with Flask. Now in case if somebody just calls the localhost URL without giving anything, I'm just calling a default welcome to complaints prediction application. Now this can also be a static HTML file or any file that you want. If you want to create an web application for your model, you can just create a HTML file, put it over here, and then in the HTML file on submit button, you can call slash score or slash check 2 URLs that we have. So we have 3 endpoints. The slash endpoints will give me just a welcome message. The slash score will give me the prediction based on the input text I pass. And then basically this particular check method will give me telling that I am alive, thanks for checking. So this is my Flask application. And what I can do is I can run my Flask application just locally. I can just tell here in the main method, the app.run, just a host, 000 is, you're not specifying a particular IP address. So it will take any IP address you're running from. And in this case, I'm just giving my port as default is 5000. But if you want to override the port, you can also set an environment variable. And why I'm doing this is when I am deploying on a Kubernetes platform, or when I am deploying it on any other serverless platform, I want to override this port from an external variable or an environment variable that is defined in my Docker file. I can do that over here. Or when you're on Kubernetes, you want to override this is the services.yaml or deployment.yaml file. So I can do that. So it's just a configuration over here. So by default, it's going to run in the 5000 port. Now, this is my Flask app. Again, the model, that the trained model is in my comments of this particular session. If you go to the comment of the video you are watching now, or the live stream you are watching now, you can see link to my GitHub repo, which has this code. It also has a video where I have covered in detail. I see some questions coming in on that aspect. So just you can look at the comment of this video and you can get that information. But think of it, it can be any model, right? It can be your own model that you want to deploy over here. Now, this is my Flask application, and let me start basically quickly run this in a local mode. Okay, so what I'm going to do is my Flask is complaints flask.py, and if you see over here, this is what I'm going to do. I have created a Flask application, and make sure you are the L check created. And one more thing you want to do, which I did not do, is in the predict function, you can have a try and except block. In case of any failure, you want to catch it and you want to log that as well. So you can say log.error and you want to log that as well. Okay, now let me run this Python Flask app. The Python Flask app you can run multiple way. You can call Flask itself and run it, or you can just say Python 3 complaints flask.py. Okay, so once it is run, it will basically start the container. Let me increase it for now. It is just throwing some exception because like I have been using some previous version of Transformer doing training and a new version of scikit-learn doing deployment, but ignore the warning. Now you can see basically the Flask is up and running. It's running in 5000 port. There is problem with running Flask in standalone. I will come to that. Flask is not production ready, but for now, yes. Let me open one other tab, and in that tab, what I'm going to do is I'm going to call this deployed Flask app is running in localhost 5000. I'm going to pass a text object, and then I'm going to see. So what I'm going to do over now is let me just first call the lcheck method. So I can just use curl http://localhost:5000/check. So when I call this lcheck, yeah, it's telling, okay, the status is success. And this is the output I have passed, right? Output is I am alive, thanks for checking. If you see, that's what I did. When you call the lcheck method, basically I'm returning this value. I am alive, thanks for checking. And that's what it's doing over here. So I know my Flask is up now. Now let me call the actual score method, right? Now I'm not going to type it. I have already copied this one. I will tell you what I'm doing. But in this particular score method, let me do a Control C and Control V. So in this, what I'm doing is I am basically over here, I am just calling the score method. I am just passing my text object. And if you see over here, I just a dictionary JSON value over here, key is text, and the value is an text file over here. And if you come and check my complaints Flask, I am taking the request.json of text object, and text is my key over here. And then I'm getting this entire value, and it returns me this value. Basically, this category is student loan. And if you read this particular text, it's telling I have a federal student loan and that is supposed to be a 0% interest rate effective, some XXXXX. So it's getting an input of this particular text. It has written me the prediction 4. Now, prediction 4, if you go to my target object over here, the prediction 4 is nothing but student's loan. It is going to get that value and print the category as student's loan. And that's what this particular thing is doing over here. Now, let me come back to this. Now we have a Flask application. We have deployed our Flask application and we have tested it. It seems to be working now. Now, what is the problem with Flask application? Now, Flask is actually a web framework that can be used for developing web application, as well as it's good for developing microservices. Right? When I say it's kind of an microservice or something like that, it falls into the category of micro framework. Now the micro framework basically are frameworks that does not have any dependency, and that's why if you see in the Cloud Shell, the way it is created, it's completely lightweight. So you can just install it. It just uses few dependencies, and then it can run application. But it was not created to be production ready, and that's why, like if you see over here, there's a warning. It tells you it's a development server, do not use for production deployment. That is one of the disadvantage of Flask, that we have to bundle in all the necessary dependency to make it production ready. Now, it is what it means is it comes with a simple WSGI server for debugging purpose, which provides a single worker. It only provides a single worker that can accept one HTTP connection at a time. So if you have, say, like 10 connections coming together, it can only take one connection at a time, right? It cannot take multiple connections at a time, and that's the major disadvantage of Flask. But at the same time, think Flask was not created for that. Flask is a good way of creating a microservice or a web application, quickly testing it, and then you have to use another production ready WSGI server to deploy it. And that's where, like, basically GUnicorn comes into play. What GUnicorn internet does, it creates multiple worker, and then it creates sockets and handle HTTP request for Flask, right? And that's what it basically does, and sends response data to it. So again, GUnicorn works internally by handling and calling your Flask code, and this is done by having your workers ready. So in your GUnicorn, you can define how many workers you want to run at a particular time, and that's what basically it does. And it's internally kind of calls one request at a time, and it can balance your Flask application request and also overcome you overcome the shortcomings of Flask, where it can handle only one request at a time. And that's what GUnicorn does it. Now, Flask and GUnicorn are a typical pattern. And again, this Flask application can be anything. If you are comfortable with the Django, go with that. If you are comfortable with Flask API, go with that. Anything. It's up to you. I'm just showing the Flask application because it is predominantly used. Right now, GUnicorn is one part of it. But again, GUnicorn, you can create multiple workers and multiple threads to scale it. You might sometimes want secure connection. How you can do that? And that's where, like, the Nginx comes into play. Where you can have a reverse proxy setting as your customer facing URL, and that can internally call GUnicorn and Flask application. Nginx has multiple purposes. Now, if you want a secure HTTPS connection, you can have Nginx do it. You can do the HTTPS handling on Nginx. Basically just a configuration. You can have your signed certificate created, and you can put it in your configuration of Nginx, and that can do it for you. Not only that, Nginx is good for handling basically static content. It is good for load balancing, and it is good for back buffering. And what is back buffering? Now, in a real world, you will have hundreds of requests coming in. Now, if you go directly to Flask will not be able to service all the 100 requests. You will get a lot of failures because Flask can handle only one request at a time. Nginx can buffer it for you and send it to you. Now, this is how your typical deployment pattern will look like, right? You have your Flask application, you have GUnicorn. If you're running on a virtual machine, and say you want to do all the load balancing and scaling. So what you can do is you can have your Flask application and GUnicorn running in one VM. And now, if you want to make sure it's fail safe and everything, you can go and run it in multiple VMs. And then how do you load balance between one VM and the second VM? And that's where you can have Nginx. Nginx can act as your HTTPS proxy as well. It can take an HTTPS connection and route it internally to GUnicorn. That is one part of it. It can also load balance. You can set a round robin that any request that comes in go to first and second instance alternatively, or you can select other kind of strategy to route your traffic. Now think about it. You want multi-data center deployment, right? If this Nginx goes down, say you don't have the bottom Nginx. If this Nginx goes down, then you will not be able to access the entire application. So if you want even further kind of failover, you can create one more Nginx, and that can call a separate set of servers and application, and you can use either Nginx again to load balance it, or you can Nginx has multiple versions of it. You can go and check Nginx documentation, or you can have an hardware level load balancer. So when a request comes in, it will go to both the say this in data center 1 and this in data center 2. It will go to both the data center. But say for example something happens on data center 2 and it's completely down. Data center 1 is still there to serve your traffic, and that's where you can have your load balancers as well in the place. right? So this is how you scale your Nginx application. But here there's a lot of manual work, right? Now if you see over here, you have to set up each and every VM, you have to run it, you have to orchestrate it, you need to make sure everything is up. Now how can I make this even more easy is you can basically first is create containers of this particular Flask and GUnicorn. Now when you are running a container with say like very less cores, like 5.5 core or 0.25 core, that's the advantage of containers. You can allocate very less memory. You don't need even a GUnicorn, because what you can do is you can have a lot of parallel instance of containers running and you can load balance it. It's also good to have a GUnicorn if you want to run with higher cores and multiple, you want to run multiple workers, right? Now you can have all this in containers, and then you can directly orchestrate this with Kubernetes. You may have a Nginx or you may not have a Nginx. That's a different story. You can still have a Nginx for HTTPS termination. It is easy because you don't want to terminate your HTTPS within individual instances of GUnicorn or something like that, which you can do as well, which is kind of an not so good architecture, but you can still do it. I'll still have Nginx to terminate HTTPS alone, because my load balancing will be taken care in this case by Kubernetes or any other server. So let's go back. Before I show a container and everything, let me quickly go through basically how you can create an GUnicorn service, right? So GUnicorn is pretty simple. You don't have much work to do. I'm not going to run GUnicorn and show it to you. I'm going to focus this in container, but I'm just going to show you how you can create a GUnicorn. This is the only code that you need to run GUnicorn. Now, what I'm doing over here is my complaint Flask is the Flask application. From the complaint Flask, I am importing my app. That is nothing but an application object I have created over here. If you see over here, this is the application object I'm created. And then I'm just calling that main method. That's it, app.run. Nothing more you need to do. It is simple 2 lines of code. Now, how you run this? If you go to my GitHub repo, I have a folder called model deployment where I have given a Docker file running GUnicorn. You can go and check that. The only thing you have to do is you need to call the GUnicorn command. You bind to a particular port, whatever you want. You tell how many workers you want to run. And remember, like if you have 2 cores and if you are running 10 workers, it's not going to work. Your workers is depends on your processor and how many cores you have. So make sure you go and check in GUnicorn website. There's a formula for it. You can run how many workers you want and how many threads you want within each worker. So you can scale your Flask application using GUnicorn this way, right? So that's the only thing you need to do to make it run on GUnicorn. Let me go and now show you how to basically create a container out of it, right? What we are going to do is we are going to take this particular Flask application we are going to create it. We are going to create a container and then we are going to deploy it on multiple environment. Now, when I say multiple environment, this is how it is. If you see, basically, you can have a standalone Kubernetes cluster or any other container orchestration framework. It can be Docker Compose or Docker Swarm or whatever it is, right? You can have anything in your on-premise, or you can orchestrate it manually as well. What you can again do is you can have multiple containers running and do it manual, which is an overhead, but you can still do it if you don't have any container orchestration framework. Or you can go to any of your cloud services. You can have it in Kubernetes. Basically, you can run it on a local Kubernetes instance, say OpenShift. Once you create a container, the container is portable to any environment. So that's why I like containers. The reason is you can bundle in all the dependencies. You can port it to any environment. I can test it on premise. I can deploy it on cloud. I can scale it on cloud. I can do anything I want my containers. It can be cloud container or a bare metal local infrastructure, or I can deploy it on a serverless platform or App Engine platform. Now, if you see serverless, I don't have Azure reference here, but Azure also, it's possible. Only thing is I'm not knowledgeable in Azure. So in AWS, you can deploy it as I have just combined both of this together with the services. The reason is some of the cloud services, if you see like very recently, Amazon released AWS Lambda container deployment on AWS Lambda. In Elastic Beanstalk, you can deploy a container. In Cloud Run, which is Google Cloud serverless platform, you can deploy a container. In AWS Fargate, you can deploy a container. In App Engine, you can in Google Cloud as App Engine Flexible, where you can deploy a container. Each has some benefit on how you want to control, but let's first go and start creating our container and then come back to slide. So let me go to my command prompt again, and let me stop this particular Flask application. Okay, let me go here. Let me clear the window. Let me first talk about container creation. Right now, in the container creation, I have some additional files that I have created. The very first file I have is Docker ignore. So anything that you don't want to go in the container, right, you can have a Docker ignore file created. In my case, I have some files called command.txt over here. I don't want that. I don't want .theie file folder that basically it is created. If you go on the top, this folder, I don't want any Python compiled files, .pyc files. I don't want any the load test folder. I have a folder called load test, where you can load test your container. So I don't want that to go into it. I'm going to cover load test separately in my videos. I'm not going to cover it today, but I'm going to show how you can load test to understand what is the infrastructure configuration you need. I'll take this as separate, because we have a lot to cover in this part, right? So that's what Docker ignore is. Anything that you don't want to go into the container, you create a .docker ignore file, and that will not go into the container. Now coming to the actual Docker file. Now, this is how your Docker file looks like. The very first thing I'm telling is I want to kind of load a Python Python environment. So I'm just choosing one of the Python like pre-image that is available. It can in a Docker Hub or anywhere else, right? So I'm calling the Python 3.7/slim. You can call any version of it. Just make sure when you're creating a container, you have only what is necessary in a container. You don't want to load everything in a container and make your container bulky, because container, one is the container image size will increase, and second is it will also take time for the container to load. So I'm just calling the slim version of Python, which is a very lightweight version. And in that, I'm going to install what all I want. That's what I'm going to do. So once I have that, it's always good to run your or either you have your custom image where you have all the Unix updates done, or here what I'm doing is I'm just running an apt-get update to update any of the latest patches of any software. And I am also installing this particular package. This package is required for XGBoost. If you're not using XGBoost, you can ignore it. But if you're using TensorFlow or something, you may need some other patch to work. So make sure you read the documentation, install that patch. So I'm just doing an OS update here with doing an update overall, and also basically installing this particular package, which is required for XGBoost. This does not come by default on the Unix server. Okay. Now, next what I can do is basically next what I'm doing is I am within my container, I am creating like an app home variable. In the sense I'm telling like where I want to copy my local file into my container, right? And again, I'm getting like a lot of questions. Just hold on till the end. I will cover as much as question as possible. Or whenever I get it, because some of the commands that I'm running will take time to run, I will cover those questions at that time. So within the here, what I'm telling, within the container, I want to create a folder called /app, and I want that to be my home folder as well. So I'm just creating an environment variable here. I am not doing anything, and I'm telling my work directory is /app home. That's what I'm calling app home. So it's going to move my work directly to under /app automatically. And then I'm telling copy dot. What it will do is anything that is there in this particular folder, it will copy it into my particular app directory /app directory. Now it will ignore whatever is there in my Docker ignore file. So it will not copy anything that is there in my Docker ignore file, and it will copy everything remaining over there. I'm just printing this command to check to list my directory over here app home, but you can ignore it. It is just just for verbose purposes. When we are running the container creation process, you can see it. right? I am setting my environment variable NLTK data. Now, why is this required? As you saw on the top, here I have something called NLTK, and I'm using my NLTK for tokenizer as well as for stemming purpose or stopword purpose, right? I have corpa of NLTK for both stopwords and tokenizing. Now, if you don't set this, by default, it will look at the home directory. But if your home directory is different from what is your app directory is, you can have this environment set so that it knows where the NLTK corpa is. Now, remember, when you are installing, when you are installing or when you are doing your NLTK training, you might have already done that. You might have done NLTK.download and you might have downloaded it, right? Now, in this case, I have to set it manually, and I am manually downloading the corpa file and keeping it in the local. That's what I'm doing over here. And once I have done it, I have to install all the dependency of my particular package. Now, I have, if you see over here, I have XGBoost, I have other packages, health check and everything. So I have created a file called requirement.txt over here, where I have given all these particular dependencies that are required from my project. So I'm creating a container which is self-sufficient. That's what I'm doing over here. So I'm telling install Flask, install scikit-learn, install XGBoost, NLTK, JobLab, gUnicorn, health-check, and all the dependency package here, the requirements. And then I'm telling basically run pip install requirement.txt. So when it's building the container, I have a Python slim version that is defined. It's going to run all the Python related dependencies over here. And then it's going to build the container for me. And finally, if you remember my Flask code, I have given the environment variable like os.getenv of that port. Here I'm setting the port as 5000. Now, it can be anything that you want to create, but I'm just setting the same one. You can change your port when you want to expose it to the user, that you can do it over here. But typically, we don't run the container by itself. We run it in either Kubernetes environment. You can run the container by itself as well. But when you want to scale, you either go for Kubernetes or you go for serverless environment or you go for other infrastructure. So in that case, it can be overridden by other definition files. In Kubernetes, you can, and if you want to know Kubernetes again, right, like in this video, I'm not going to go details into Kubernetes. I'm going to stick on to serverless and App Engine. But if you want Kubernetes, you can go again to my model deployment folder in my Git repo. And I have given all the requirement files over here. Just a minute. If you see over, I have like an complete code over here. I am telling like how you can basically run it in your Kubernetes environment. I have given all the instructions over here and the video on how to run it also here. You can go and check Kubernetes. I'll be doing another one live session on Kubernetes with the same model in the next, but for now, I'm going to focus on serverless. Right? And serverless internally runs all the infrastructure for you. So in some cases, it may just run the Kubernetes for you as well, right? I will talk about that. And then finally, I'm telling what I want to run. I am telling here command run Python and then run the complaint flask.py. Now you can also run gUnicorn over here. If you want to run gUnicorn, you can just change it to this one, but I'm going to stick on to just the typical Flask for now, because I'm going to use my serverless to scale it for me. So I can give like a minimum version of serverless and let it scale it for me, right? But it's good to have gUnicorn as well, right? So you can do that as well. Now, this is what my Docker file is. This is how you create a Docker file. Now, one thing, if you notice, when I'm copying this file, it is copying a lot of data. It is copying the NLTK data. It is copying my models as well. My model contain my tokenizer and XGBoost model. When you're running your, say like TensorFlow model, it can be very bulky and very heavy. What you can also do is you can create a external mount point or external volume and keep all the file over here, and then you can load it when the container is running. You can do that as well. That way you can reduce your Docker file, reduce your container size even further. You can do that as well. But in this case, I'm just copying everything in my container and I'm running it in the container. These are some best practices you want to follow if your model is very bulky, but it's okay if your container size is big as well, but if it's manageable. But if it's not manageable, then better like have it in external volume and load it, because I know some enterprise has limitation on how big your container size can be. In that case, you can keep it in external volume and run it. Now this is how my Docker file looks like. And what I'm going to do is I'm going to once run this. Basically, if you see, I have everything over here. I have my Docker file. I have my Docker ignore file and everything over here. Docker ignore file is dot. So let me do an ls-al. You will see the Docker ignore file as well. Now let me create a container image of it. So for me to create the container image, what basically I can do over here is I am going to say like now when you want to create a Docker image, you will just say like Docker build in your typical Docker world. Now the only thing I am doing is I'm changing it to G-Cloud specific because I'm in the Google Cloud environment, right? But you can use the commands are exactly same. Only thing is you're using a different version of command in your local, or if you go to AWS, you may have a even different version of command, but internally it does all the same. So what I'm going to do is I'm going to say G-Cloud builds. This is the command to build the Docker file. And then I'm telling submit and -- tag. And then I'm telling now, typically you will give your Docker hub location. In this case here, the Docker hub, internal Docker hub for Google Cloud is Google Container Registry. That's why I'm giving like gcr.io, and I'm telling my project name. If you go over here to my home screen, you can see this is my project name, Srivatsan project. You can have multiple projects created. You can just click on new project and create a project. Why I create a new project is if I have multiple projects and I want to monitor billing separately, I want to set alerts for billing separately, then I can create multiple projects and as well do it over here. That's what it is. Right, but this is the projects. Let me come back to Cloud Shell. I'm just doing a G-Cloud build submit tag gcr.io, and I'm giving my project name. In this case, I want to deploy in Srivatsan project, and then I am telling what is the name of that particular deployment I want. I am telling basically complaints API, and I'm just telling the current directory is where my Docker file is, right? It's G-Cloud build submit tag is where you want to deploy in your container registry, and dot is over here. So once I run this, it's going to, I'm just going to say authorize, and it's going to take my Docker file from the local, and then it's going to basically start creating all the Docker. You can see like whatever we have created in the Docker file, it's going to basically create step by step and create the Docker environment. We can also monitor all the logs and everything, which I will show you once we get there. So now it's just creating like with all the files, it's 78.1 MB before compression. It's going to create it. It's going to upload the tar file and see here. Now it's going to start your Docker image build. So let's just give it for some time because I want to show the steps it does. Whatever we have given in the image, it's going to show it. If you see over here, the step 2 was run apt-get update. It's running the apt-get update on the container. It's pulling all the image, and it's kind of basically, if you see over here, it's setting the environment. It is running pip install requirements. It will read the requirements file. It's going to install all the requirements that I have given, and it's going to build the container. And how do you check the container? You go to your home directory in your Google Cloud. You go to container registry. Now, if you are in Docker Hub, you will go to Docker Hub. I'll just go to container registry. Now, container registry is where my final model will get saved. I'll go to complaints API. This is one I created some time back, but it's going to create a new one and put it now after this complete. It takes some time to create the container. It's going to do everything. So while it is creating, let me see if I can quickly take one question while you can monitor it. Let me try to come from the top. Okay. So it's telling like where can we get the code which you have used for Flask application. Prashant, I will put all the code in my Git repo after. Give me a day or two. I will just arrange and put everything, or everything will be available, and then I will tag it back to the same video where you can come and check my description to get the location. So I will do all that. Would it be possible if you can put some light on Sheldon Core, MLflow, TF serving as well in the future? I will try to do that. But if you go to my channel, I have a video on MLflow. TF serving was something which was covered like a couple of weeks back by one other person. So you can check that as well. Basically it's some of these are already there, but Selden core and everything I will try to do it in the future, as videos, right? I think my Docker is created now. Let me you can see basically, okay, it has been successful over here. My Docker is created and everything. You can go to the container registry. Let me go back, and then let me come over here, and you can see the latest version is that was built 1 minute ago. So I have a latest version of this particular container. So we have a lot more to cover, so I will be moving a little faster, but still now we are not deployed the container. But what I'm going to do now is quickly how you can validate the container, right? So one thing, how you can check what all container you have. One way you can do is you can just do gcloud, basically again the builds, same one, gcloud builds. Yesterday previously I gave submit. You can list all your containers you can have, and if you list, you will have hundreds of containers, everything will come place. I can just filter it by my name. I have given complaints API as the name. I'm just giving complaints over here. It can be partial name, so it will show all the containers I have. And this was the latest one on 9th Jan I have, and this is the container ID. I'm just going to copy the container ID, right? So this is the container ID I have. So this is how you look at all the containers you have created. Now what you can do is you can also describe this particular container. Let me quickly go to the previous command, and instead of list, what I can do is I can do describe, and then I can give the container ID I copied. Just a minute, Control V, and then I can run it. It will basically go and describe the container, when it started, build, and everything. Now say you want log of the container, you can do that as well. What I can do is instead of builds, instead of describe builds, I'm just calling log with the container ID we copied, and then you can get the entire log of the container, what all happened. So in case some failure comes when you are building this particular container, you can go into the log and check where it failed and then rebuild the container. Okay, so that's what it is. These are different commands by which you can access the container. Now let me go and deploy this container in a serverless environment, right? Let me go back to my presentation. Now this is what it is, right? There are multiple ways your container created. The container is same whether you run it on premise, whether you run it on AWS, whether you run it on Google Cloud Platform, or whether you run it on Azure. Nothing changes. That's the best thing about container. You have all the things bundled in within your container, and it is ready to deploy, right? So now in this case, you can run it anywhere. I'm going to run it on these two ecosystem and show it to you. First, I'm going to run it on serverless. I'm going to use Google Cloud Run to run it, but it can be anything. It can be Fargate, it can be AWS Lambda container, which was recently launched, Beanstalk, or it can be anything. Why I have combined these two and put together is the way all the cloud system is moving is they are trying to make a basically serverless as like one runtime environment where you can orchestrate container. So the way the app engine and serverless are coming together, and you can see in couple of years there'll be no much distinction. The only difference is basically serverless allows you to focus on the code, not on the infrastructure. You can build and run application without thinking about serverless, without thinking about servers and serverless. Like with servers computing, the infrastructure management is taken care typically by your cloud providers. So you focus only on writing code that serves your business purpose and generates real value out of it. So you forget about infrastructure, they will allow you to scale. But there is a drawback as well. Now, what serverless will do is, as you get more requests, it will try to typically scale up to hundreds of nodes or whatever it is, and it will scale down to zero when nothing is coming. So say if you get a new request when nothing is there, when no server is there, there may be a problem of cold start to bring up the server initially, which is a light overhead. I will not tell it's a big overhead, but in some application which are time sensitive, you want better control on it. And that's where you can go to semi-managed infrastructure like App Engine, where you can control how much minimum nodes you want to keep running, so that like even if some request comes in, you are able to service it, right? That's what you can do with the App Engine. There are some differences, but overall, like there are a lot of enhancement going in this space where you can control what is the minimum server you need up and running. right? In serverless, you are charged only for the amount of requests that comes in, right? You are not charged for running any VM or something like that. You're charged by request, so it can keep your cost low. Kubernetes give you a lot of control, and I personally like Kubernetes because you can control how much you want to run, how you want to scale, and how you want to maintain. But there is an overhead of creating clusters and maintaining it that can be typically automated by various processes, right? So let me go back. Let's now deploy it on a serverless environment, that is Google Cloud Run. Now the command is going to be same, gcloud, and what you're telling, instead of gcloud build, where to build the container, we are going to say gcloud run to run it on Cloud Run. I'm telling deploy. Now, what am I going to deploy? I'm going to deploy, I'm giving a name complaints API again. And then I'm giving my image that I have created. So I'm giving hyphen image. The image that I was created was gcr.io slash my project name. This is what the name I gave when I created my image. Srivatsan project slash again complaints API. Okay, so basically if you go to my this is what I'm doing, gcrs project Srivatsan project complaints API. This is, it's going to take the latest one, but if you, what you can do is you can label and tag each of this deployment, and you can just say like colon latest or colon tag. You can go to a particular deployment also. Typically when you want to run in an champion challenger mode or something like that, you can do that as well, right? So I have this image, I'm going to take this, I'm going to go and deploy this in a Cloud Run. So let me run this. It's going to ask me, how do you want to deploy it? So one thing I must have given is I must have given platform manage. Let me do one thing. Let me do a Control C and let me open it. And what I can do is I can say like iPhone platform. I can either say fully managed. I can use Anthos deployed on Google Cloud, Anthos deployed on VMware. Anthos is basically Google service for running hybrid cloud. So you can run it on-premise as well as cloud without any difference, right? But I'm going to say platform managed. I'm going to add few more parameters, and I'm going to tell hyphen memory, how much I want to give. I'm just telling run it with 1 gig memory. Let me run this. It's going to ask me to select which geo I want to run. The closest geo is for me is US West 1, which is here, which is 21. I'm going to give 21. You can select your closest geo, right? And now I'm not going to set any security over here. I'm going to tell allow unauthenticated invocations, yes. But you can set security as well and policy. It will start deploying this particular service. Right now, let me go back and see if I can take some question while that is running, and you can watch my screen. Can I ask regarding IT out of which you are teaching right now? I am using Google Cloud. If that's what you're looking for, I am using Google Cloud to run it. But you can use PyCharm. You can use your local deployment. If you have Docker, you can use anything. If you want Google Cloud access, you can go and get an free access for 1 year. They give you $300 credit, which you can practice all these things. Okay, so that is what you can do. Then that was asked by Bikers World, but okay, so I'm just thinking, how can we use Flask app using HTTPS? And the next question also, so yeah, so Nginx is a good way to convert your Flask app into Nginx. Basically, your Flask app to provide SSL layer. Typically, I have front-facing Nginx where I can take the Nginx data and route it back to my Flask app. So you can terminate your SSL and give all your certificates in the Nginx configuration file. But said that my service is deployed in this particular URL. Let's first go and check over here. Now, what I'm going into, in order to check Cloud Run, I will go to Cloud Run is a service that I'm going to deploy on. It's a complete serverless environment. If you see over here, I have not spin up any services, right? Everything I am kind of ready. I'm going to allow the cloud to manage it for you. If you're on AWS, you can use the AWS specific services, right? Now, this is how it is. This is how my complaints API, it was deployed few minutes back. You can see Jan 9th. For me, it's around now 8:58 a.m. It was deployed few minutes back, and you have this particular app deployed. Right now, it's ready for servicing request. Let me, you can click and you can give you a lot of information about this particular service. All these things, you can see the logs and anything you want. If you go to logs, I want to show the logs because like I gave some logging information. I want to see if the logging information has come in the logs. So here, if you see, this was the in the Flask, I gave all models loaded successfully, right? Now you can see basically over here, I have given the logging info my Flask app, and it's printing that out, right? So that's where you can see all the logs and log as much as possible. What you can also do is you can take these logs and basically move it to your own logging infrastructure, or you can basically have your stack driver, which is Google Cloud, also monitor it, and then you can use it, right? So I can also check whether it's up and running. You can see basically all these things, whether it's up and running or not. It's basically up and running. All this information is there. It was deployed on 857.901, and you can see everything. That's what the logs is. Now let me go back to the Cloud Shell. You can see this is what is my URL, right? So what I can do is I can quickly copy this URL just to make sure it's running. Okay, so here I'm just copying it, and then I am doing /check, which is nothing but what is happening. Wait a minute. Just a minute. Okay. Sometimes it behaves crazily when I copy. And there is no. Okay, it came service URL also. So, and there's no demo without any goof ups. Just give me a minute. So I am running this and I'm running lcheck, and basically, okay, simple root key mistake. I'm not given curl. I had to use curl to call the URL, and then here it is. So it's going to go and hit the complaints API and basically give me the output. It's taking some time because first time it will create the infrastructure to make sure it's running or not. What I can do is I can click on this link. See, the first time, this is what I told you. It has a cold start problem. So it scaled down to 0, and next time when you run, the containers is up and running. That's the major disadvantage of serverless. But think about it. If you're running a batch application where you're okay when the first request is basically taking some time, and after that it's very fast. After that, every time I run, it's going to be fast because it has started the container. It knows like I can expect more. But if it's going to wait for some time and bring it back to 0 again, right? That's what it does. If you click on this link over here, it will just show you welcome to complaints prediction app, because when I call the root URL, that's what I had given in my Flask app. But you can also have a static HTML page which is describing your app, and you can build jazzy things out of it, right? And here it is. I didn't do anything to deploy it. I just ran a command. So how easy it is to deploy and container, right? Now let me go and run the actual value to get the output. So I'm going to go to my APIs call, and in this case I'm going to run the same thing which I ran with my previous Flask container, but now this time I'm going to call with the Cloud Run URL. Let me clear it out and let me copy paste it, and you can see basically I'm calling the curl, I'm calling this URL with the same text, and it's giving me the category students loan and everything over here, right? So I took a Flask app, I created a container. Now I have run it in a serverless environment. Now you can also run it in Kubernetes, right? Again, it's going to just, we have to create some cluster. You can run it on any Amazon environment. It can be ECS, it can be Kubernetes service, it can be Fargate, it can be Beanstalk, or it can be Google Cloud Run, App Engine, and similarly on Azure. It can be that environment, right? Now, what I'm going to do is I'm going to kind of go back here, and then I'm going to show how you can deploy it on App Engine. Right now, Google App Engine, basically I have created a new project for it. If you go over here, one more thing, right? You can go and check all your logs, refresh logs and everything. Let me go back to my home page. And now I have a project called Srivatsan project. What I'm going to do is I've created one more project called Srivatsan app project, and I'm going to deploy it over there. The reason is I can just delete the project after I am done. So I've just created a new project over here. Okay, so now let me go back. Let me show how to deploy the same thing in App Engine. Now, before going there, I will take the questions right after this, because App Engine deployment takes time. In App Engine, you don't have to really build a container itself. It will take care of building the container and deploying it. So in this case, what I'm going to do is I'm just going to open the only additional thing you need to do to deploy an App Engine is create an app.yaml file. in this say like runtime custom, because we are having a custom container to deploy and just telling runtime custom. App Engine Flexible and App Engine, there are two different things in Google. App Engine allows you to deploy a Python application itself. If you are familiar with Cloud Foundry or any other deployment environment similar to that, you don't have to create container, Docker file and everything. You can deploy the Python app, bundle all the dependency. But since machine learning projects typically have a lot of dependencies, what typically I like is I try to create a container. That's why I want to create a custom runtime, and I'm giving environment as App Engine Flexible, right? These are the only two parameters that you need to add to your command. And what I can do is, let me open a new tab over here. And the very first thing I'm going to do is I'm going to create a separate project. Currently, this project is there. I told you I want to deploy it on a different project altogether, right? So to do that, I can just say over here, gcloud config set project Srivatsan-app-project. Okay, so it just set up, it just changed the project from my this project, other project, and I am going to use that. Let me do an ls and make sure I'm in the right folder. No, I'm not. So I have to move in the complaints folder, which is where all my file is. And then let me do ls, and you can find all these things. Okay, now it's very simple to deploy it on your basically App Engine. I'm just going to say Google gcloud. Rather than builds or run, I'm going to say app, which is for App Engine, and I'm going to say create. Okay, now what it's going to do means it's going to just create, and it's going to just tell, okay, it's created, now just deploy it. Now to deploy it, I can just say gcloud app deploy. Okay, it's going to start from beginning. It's telling unable to deploy, status user disabled. Okay, so I'm not able to deploy in this project. What I'm going to do is I'm going to go back to my original project, and then I'm going to say like Srivatsan project and try deploying it. Maybe I didn't give some sufficient permission to this project when I created it. Let me do this. Let me again go and check if I am in the complaints folder. Let me go back and say app create and say like app deploy, and see if it works, or if they have disabled me. Yeah, so it is starting to create this particular resources. It will take some time to deploy. Let me, it's asking like this is what it is. It's going to create as a default service, and showing all the parameters and how I can access the URL. Just say yes, and then it's going to start building the image based on the Dockerfile. It's not going to take the image that we have already created. Okay, and it's going to build the image, it's going to build everything. And if you go back to the container registry, it's going to create its own container registry image, right? So that's what it is. So while this is going, let me go back and let me kind of take some questions over here. Okay, just a minute. What if I don't have any SSL certificate for a particular Flask URL? So see, like depends on how secure you want it. You can have your own API gateway. You can have everything. Certificates are a good way to terminate your SSL, and trusted certificate. You can also create a certificate quickly. You can just use OpenSSL or other framework to create your certificate quickly, which is nothing but non-signed certificate, which you can use it for test purpose, and you can do it. Will the session be available after it ends? Yes, it will be available. The recorded video will be there, and you can use it. Okay, so those are some of the questions. I have a question. Do we need to set up SSL for every Nginx, or we can set it up in load balancer? Yes, you can set it up very well in the load balancer. Load balancer also typically come with SSL termination. You can also have an API gateway that can nothing but call your load balancer virtual IP address and then route it. You can do that because if you have multiple Nginx load balancing, you don't want to do it at each and every level. You can do it at the load balancer level, or best practice is to have an API gateway before all of this, right? I know there are a lot of questions on SSL, but like just a minute, I'm still catching up with. See, in case the app deployment fail, I have to run it again. For some reason, I have seen this crazy bug in Google App Engine. When I create a new project and run it for first time, it creates issue. But let that continue. Okay. Can the request be queued for Flask application to serve the request? Yes, it can be queued. Nginx is a good way. As I said, black buffering is there. If you want Nginx, you can use as back buffering and then call Flask directly. But the best way is have gunicorn, which will parallelize the request so that your Flask does not wait indefinitely and your queue does not get accumulated. So it's like better to do that. I am new to the container. Where do you suggest I should start with? There are a lot of free environment. I think I forgot the name, Kataconda or something. Kata. I'll just do one thing. I'll post it in the video description. You can go and search. There are environment that allow you to train Docker, run Docker commands and everything. It's completely free. Kataconda or something like that. I think I kind of forgot the name. You can go and check over there. And thanks Hassan for answering some of the questions. Yeah, you can do like all this your courses in Udemy, Coursera and everything. But it's pretty easy once you know the format. It's about like how you are deploying and how you are getting started with it. Again, if you see, basically when we deployed it on our cloud and environment, it was pretty fast. App Engine will take some time because it is going to create container, it's going to deploy it. It will take some time. So that is that. Share some books which covers comprehensive details of practicing ML, DL, data engineering aspect on GCP. I have not read any books on GCP. There might be books. I have not read any books, but that documentation is pretty good. I have detailed video on basically Google Cloud AI platform, which you can check. I have a couple of other platform. I'll do one thing. I'll create a playlist and add it to the video description as well, so you can go and check. I have planning some few expert sessions on Google Cloud ML. If you want TensorFlow, I had like one other expert speaker last week, Asan, who he had done a deep dive into TensorFlow. So you can go and check that. For TensorFlow, there are a lot of resources available in TensorFlow website itself. You have to just go and practice it, which is already there. You can go and check that out. Okay, and then when you are deploying image now, I suppose the cluster is already created. So when I use serverless will automatically create a cluster for me in the backend, but it will not scale the application. Now, in case of when I'm running in Kubernetes, the container in Kubernetes, I have to create the cluster. And if you go to my Kubernetes video, at which I showed you in my it's in my playlist, or if you go to my GitHub repo, you have the code. There is a command which will allow you to create the cluster for you and define the cluster parameters, right? So you can do that as well, right? How to access it, please guide. Yeah, I didn't get that question, Shivang. How to access it? If it is how to access if it's how to access G Cloud, you can go for Google Cloud free credits. You can go there and just give your Gmail ID and register it, and you get. Earlier it was for 1 year, but I think like it is now 3 months. I'm not exactly sure, but you have that time. The $300 is very good and very sufficient to go ahead and work on multiple things on Google Cloud AI platform. Just don't run my AutoML video alone with that, because once you run the AutoML video, it will take up all your credits. So you can AI platform, Cloud Run, anything, Kubernetes and everything you can run. Okay. Now the next is I hard code the port number and then I try to deploy it in which might bind it to some other port. Will my application crash? No, it will not crash, because what happens like when you want, okay, that's why if you see I have given in my command the environment variable, right? So that's what you need to do. If you're hard coding it and starting it, you can still go and bind it in when you're running the Docker, you can bind it to a different port outside. When you are doing like external, you can do the binding. That will work, because internally you are running in some 5000 port and you're binding externally to some 5000 port to 80. That will still work. But if you want more Kubernetes and configuration driven, you have to do it in the YAML files and everything. Or when you are doing Cloud Run, just make sure you define the port variable, which they will automatically update for you. Okay. Does Cloud Run invoke GKE in the backend to spin up service and orchestrate it for scaling? It runs backend. Yes, I am not sure exactly, but internally, yes, it should run some kind of Kubernetes or orchestration framework for us to run and scale it and scale down, right? But I have not gone through the documentation of what run, but by definitely they will run some kind of Kubernetes engine on the backend, both for App Engine Flexible and it is. And if you see over here, the App Engine is still running. It takes time, so I have a lot of questions to answer and show it to you. In case if it fails, then I have to start it again. That's one first time problem. Okay, so you don't need Docker file for App Engine. You need Docker file, yes. The reason is you need to inspect your dependencies, but you don't have to create a Docker image is what I meant. You still need a Docker file. The Docker file is in the directory. It will create a separate image. Let me go and show it to you while I am talking. If I go to my container registry, and then if I okay, so I have to change the project because I went back to my previous project, and see here, App Engine has created that container registry for you with all the parameters. So you do need it, and the but you don't have to create the container. You don't have to give the container. Okay. I have 1 year free account of GCP. We need a credit card to check out. Is there any other way if one do not have credit card? I think they clearly say, if you really see, right, they clearly say that they don't charge your credit card. They just keep it. And I have seen Google Cloud. It is not like other cloud where they start charging. They will give you a lot of alert, and they will not charge your credit card. I am not sure if there's a way without credit card. There should be a way, but I'm not sure. I think this is run now, and I have the app up and running. Let me go and complete this and come back to the remaining questions. So you can see basically the service is up and running. Now I can go here. I can go and search for App Engine. Okay, and I can go over here to App Engine settings. I can go to my dashboard, which will not the dashboard, which is the other version. It will actually tell me like, okay, there is one that is serving now. It has 2 instances up and running. Now, if you see basically in the cloud, it was 0 instance. It has run 2 instance, and you can go in the configuration. It will tell how much it can scale up to. You can see the instance level details, what instance are provisioned. If you have a lot of requests comes in, the App Engine will scale it for you. So now it looks like it's up and running. I can go and click this URL. Okay, it is not allowing me to click the URL. Let me try to copy it and then open a browser and then do Control V. You can see it's telling that welcome to complaints prediction application is up and running. I can also do curl and copy this one, and I can say basically a check, and you can see it's up and running. And you can see even the first request, how fast it was. That's because in serverless engine, you had that initial cold start problem. And then basically in the App Engine, it is already running with 2 instances for you. But see here, they're going to charge you for the 2 instance, not like serverless where you don't have and it's 0, they're not going to charge you. So that's a cost. But again, you need to balance between cost, latency, and multiple other parameters as well. And you can also go, let me go to the API and let me come down, let me copy this. You can also call the actual URL that gives the prediction output. Let me go on top. Let me clear it and let me run this. Okay, it says there is an error. Oh, I got it. I have to change the project. Okay, let me, because I have the wrong project, let me go here. And then it's okay, Srivatsan project WNR. So I'll just remove this app from here, and ideally it should work. If it does not work, I will manually type it. Okay, now let me clear it. And yeah, so now if you see, basically I got the prediction as well, right? So this is how you run it on your App Engine. And let me go back and let me try to take few more questions. You saw basically we created a Flask application. We kind of deployed it on a serverless environment. We deployed on an app engine. There are multiple way deployed. There is Kubernetes as well. And then I will tell you like how to do it in Kubernetes. And I think like, let me see how much questions I can take more. I will try to take as much questions as possible. So the next question is knowing all about model deployment necessary for getting an ML engineer? See, when you go to a real world, right, you at least need to know the basics. You don't have to know like every possible way of deploying and deploying a model, right? You at least need to know like what are the different options available. It is good to know, and these are all, you see, some of the things. You just create a Flask. What I did is I created a Flask application which is similar whether you run it in local, and then I created a Docker image, and everything's taken care by infrastructure. So I would say if you want a ML engineer, a lot of companies in the future will run ML on cloud. I said lot of, not all. There will be many that will be running. So it's always good to know one cloud platform. That's what it is. But it is not mandatory as well, right? It's Kata Koda, and thank you for telling me. Somebody asked me like how you can learn Docker, and it's Kata Koda, and basically that's what it is. Okay, and then just a minute, like there are a few others. Okay, somebody has recommended book as well. You can check it. End-to-end real-time data pipelines. So Valyappa Lakshmanan. Valyappa Lakshmanan is an expert in this space, and definitely his book will be good. I have not read it, but definitely it's a good book to read. So that is one question on computer vision model deployment. In my case, I have a deploy a set of model on a client machine, which will take images from camera, process the image. Now, when you are running your when you talk about like camera, what you can do is, one more thing I wanted to mention, right? When you are running on Google Cloud Run also supports event-based scoring, right? So what here I did is I called an API deployed in a Flask. You can take the same Flask and you can create a real-time streaming pipeline, and you can call, and if you're on Google Cloud, you can call an PubSub component. PubSub is similar to Kafka. So basically you're putting the message and then getting the response back. So in that case, you can have your camera app, which can either call the API deployed in similar way, or you can put it in a PubSub event to define an event-based architecture. You can do that as well, right? And return the final results to a C# application. Yes, you can do this. You can have an input. You can also deploy it in an event-based architecture, is what I have mentioned. Okay, so I think Sachin, maybe that answered your question. If you have anything, you can message after this. I think you have a lot of comments, so you can message after this, and I can answer that in my video as well. What is the next question? I really like formulating. Thank you, Vijay, for sending this feedback, and thank you, everyone. There will be a time when we need you write your name in our CV. Okay, yeah, sure. And the best thing is, like, I have a lot of playlist where you can go and practice, where you can put your portfolio in your project rather by kind of name, right? You can create your own portfolios. I have like if you take the project itself, which I was talking about here over here in my GitHub repo, the basically complaints. This complaints data set is a real world data set. This is customers who have really complained about banks. The CFPB has made it public. You can play with it. You can and if you see this particular code, I have done a lot of imbalanced data handling. You have a lot of information over here which you can run and help you build your portfolio. You can take it and deploy it as well. You are basically creating an end-to-end project for yourself, right? And one more thing, if you like my videos and live sessions, do give me a shout out in LinkedIn so that like more people can follow and join the session in future. The only thing that helps me is the number of people joining in the live session or number of people watching my videos. My channel is not monetized. My only motivation is more and more people come watch this particular videos and everything. And I think that's about it. Thank you everyone for joining this session. This recording will be available and you can watch it anytime. That's about it. Thank you till we meet in the next